Okay, so what we have at this point, we're doing I did my dilutions kind of in the background. Again, kind of the cooking show, but you guys have written hopefully directions on how to do your dilutions from whatever the concentration was of our stock solution down to 0.20 was my first dilution, and then I did one at 0.1, and I did one at 0.05, and then I did one at 0.025, and there's 50 milliliters of each of these, and of course I have 100 milliliters the last one just because of the way I set it up. But those were my 4 dilutions. I took each of them and I placed them in a cuvette, and the cuvette is what we're going to use in the colorimeter to determine their absorbance. And so on the far left over here, this is the 0.2, the 0.1, the 0.05, and the 0.025, and you can see a scaled difference. It's getting more transmittance. There's less being absorbed as it becomes less concentrated. And so this one is by far the most concentrated, this one being the least. Over here on the far left, I have my blank. So I have a cuvette so that I can zero out my apparatus, my colorimeter, which is like a mini spectrophotometer. So let's get started. So what I'm going to do is I'm going to blank each one of these. I'm going to place that, well, I'm going to blank with the water. I'm going to wipe the clean. Let's just show you. Here we go. So our colorimeter is up here on the top. And what I'm going to do is I'm going to take my my water cuvette, and I'm going to wipe the transparent sides, not the ridged or ribbed sides. That's what's for your fingers, but the transparent, translucent side there. And I'm going to place it in so that the arrow points in the direction of the light beam. And I'm going to close it, and then even though it says 0, I'm still going to go ahead and calibrate it. And so you press the cal button on your colorimeter until it stops flashing, and it says 0.00, which it does now. Stop flashing. There we go. And so what I can do is I can remove my blank, and I'll take my first measurement of my 0.1. So this one is one you'll want to write down, the absorbance reading for 0.1. One thing I forgot to mention is that you need to make sure you're on the right wavelength. From what we talked about before, we're going to want something on the opposite end of the color spectrum, right? So we're going to want something high in long in wavelength and short in high in frequency. Sorry, long in wavelength and short in or small in frequency. Anyway, so we want it at 635. So that'd be on the other end of the spectrum from the blue, which would be a much smaller wavelength. Okay, so if we go here, our actual absorbance for the 0.1, oh sorry, not 0.1, 0.2. I'm sorry, 0.2 is our highest. For the 0.2 is 0.44. So make sure that you have, for the 0.2 molar solution of copper 2 nitrate, that your absorbance reading is 0.44. All right, so now I'm going to pull that one. And just to be perfect and like you're supposed to, I'm going to go ahead and wipe and blank in between each of these. It's really not necessary in time, but it is the right thing to do. I also probably should use the same cuvette for each of these, but I did want you to see the difference in colors across, and it doesn't introduce that much error. So once the cal button stops, oops, I'll open it up, take it out, and I will place in this time my 0.1. So this is my 0.1 molar, wiped, placed in the right direction, and there you have it. So for 0.1, you want to record 0.21 as your absorbance reading. So we'll go to the next one. I'll blank it again. Okay, it's blanked and zeroed out. Now we're going to do our 0.05. So wipe it again. 0.05. That is your reading for 0.05. So it'll be 0.11 is your absorbance for a 0.05 molar solution. All right, I'm going to remove that. I'm going to blank it again. And then we'll do our last reading after that. So the last one that we will do, I'll go ahead and wipe and get it ready, but the last one that we'll do will be our 0.025. So remove our blank, and this will be our 0.025. So our absorbance reading for the 0.025 is Come on. Well, you could choose, I suppose, 0.05 or 0.06. It seems to be, let's just call it 0.05. So it's on 0.05. Okay, so those will be your absorbance readings. Make sure you write those down so that you can graph your results and then predict. We need to do the absorbance reading for the gun shell casing. Oh, that's my mistake. We need to do the gun shell casing. Oh, well, I'm going to do the gun shell casing on a separate video. Sorry, guys.